Okay, we're doing Chapter 6, Test C. And on number 2, and it says, sketch the area that this is between 0 and 4. So I pull out my calculator, and it looks like it goes through, if x is 0, it goes through 1. And if, as x gets bigger, this denominator gets smaller, and it slowly drifts up. Not very high. I'm not too concerned about that, other than that's the area between 0 and 1 and in the first quadrant. So it's this area. And it's rotated around the x-axis. So if this is up 1 and that's the x-axis, it's going to come and go to -1. And it's going to drift down like this. And this is the bottom half. So there's 3 points, getting the graph right. And to do the volume of something rotating around the axis, this would be pretty easy to do with just a disk. Make a slice here and bring it this up and around and down to there, so it'd hit down there. And since it's right on the x-axis, there's no hole in this, so it's just going to be the integral of the area of this disk, which is pi r squared, and the thickness of the disk is dx. The thickness is in the x direction. And we're going to integrate from x going from 0 to 4. Now, the only problem is we've got an r. But r is going up to the curve, and any point on the curve has the coordinates x, y. X being how far over, and y being how far up. And how far up is what we are interested in. This is the center of this rotation, and up to here is the radius of that rotation. So r is equal to y, but we have to turn it in terms of x, and y is equal to this. So we've got to put that in place of the r, and this becomes pi integral from 0 to 4 of 1 over the square root of 1 minus 1/100th x squared dx. Oh, but it's r squared. So this becomes pi integral 0 to 4, 0 to 4. 1 squared is just 1, and the square root of something squared is just 1 minus 1/100th x squared dx. That would be pi, the radius, the y, squared dx. You type that into your calculator, and you get the volume of this, which turns out to be, let me see if I can find my key, 13.309. 3 points for a graph, 3 points for getting it set up, a couple points for getting the answer. Now let's do number 3. It says we've got y equals x squared. That's something that you should know how to do pretty easily. I'll draw the line there, and since it's in the first quadrant, I'm going to put my y-axis there. And 0 squared is 0, 1 squared is 1, 2 squared is 4. It's going to look like this. And it continues on over here, although I don't need this part. There's my y equals x squared. my y equals 2. X equals 2, excuse me, x equal 2. Not y equal 2, x equal 2. Okay, and the x-axis. Well, those don't capture this. This is unlimited. This is unlimited. It captures this area. If you do up here, that's not limited. This is the only enclosed area. Enclosed by this axis, x equal 2, and the curve. So that's the area that I need to graph, 4 points. And then I'm supposed to rotate it around y equal minus 1. This is x equal minus 1. Y minus 1 is down here, down there, down there. These are all y equal minus 1. So if I take this region and flip it over this, the x-axis is 1 above this line. So when I flip it over, it's going to go to 1 below that line. This line is going to stay the same place. And the curve, if it's 1 above the axis, it's going to be 1 below the axis. And it's going to do the same shape. So it's going to go roughly like that. And we're talking about this area. That's this area flipped over here. So there's the 4 points for the drawing. Now I said 4 for just getting this, but I'd really like to see that. So 4 points for getting all of that drawn. Now, disk. Here's the axis. We slice it perpendicular. Slice the area that we're working with. So I'm going to slice it right here. It's a random distance over. But its thickness is in the x direction, so it's got a thickness of dx. I think the thickness of my pen mark. And if I follow that up and around and down to here, it lands here. And this one goes up and around and lands there. Now I could try to draw some kind of arc on those, but it gets a little hard to see. This should look like a disc with a hole in it. Okay, so to do the disc or washer, this would be a washer because it's got a hole in it. It's going to be pi r squared minus pi r squared, the full radius minus the hole, d, and in this case it's dx because the slice is perpendicular to the axis. If the axis was this way, the slice thickness would be, the slice would be this way and the thickness would be dy. So as long as we've got it set up going counting x's, x is going to have to, this shape goes from x equals 0 to x equals 2. Pi is in both of these, so I could pull that out. And what is my large radius? I like to start at the center and think about going to what's controlling the large size. If I follow this, let's do it with markers here so you can follow it a little better. That's going to be this distance between my pen points, and it gets bigger as I go out, gets smaller as I come in. but that distance is simply the y height. If this is a point on the curve, x, y, this is up y and over x, so it's just y. So r is equal to y. But my variable is supposed to be x. So I have to replace, oh no, that's not my big radius. That's the distance from here to here. The center is down here, so it's 1 plus y. That's my big radius, sorry. Big radius. From here, I got to go 1 plus the y amount. But I got to be in terms of x. So y is equal to x squared. So this first part is going to be pi times x squared plus 1, y plus 1, quantity squared. Now the inside radius, that's also times pi, the inside radius goes from the center up to this green line, and this green line doesn't change anywhere along here. That small radius is the same all the time, so I don't need to put a variable in for r. I can just say that radius is 1. And I'm subtracting out the inside circle from the whole disk, the inside disk from the big disk, dx. Now if I work this out, if I wanted to work this out, this would get me my 6 points for this. But if I'm going to square this, x squared plus 1 squared, x squared plus 1 squared, then I get x to the 4th plus x squared plus 2x squared plus 1 times 1 is 1 minus 1 integrated from pi times this integrated from 0 to 2 dx. It's all in x's. The 1's cancel, and so I need to find the antiderivative of x to the 4th, which should be raised to the power of 1, would be 5, so it's 1/5 x to the 5. Raise this power by 1 makes 3, so it's plus 2/3 x to the 3. Evaluated from 0 to 2, and all of this is times pi. So if I put 2 in here, I get pi times 2 to the 5th is 32 over 5, plus, if I put 2 in here, that's 8 times 2 is 16. Put in 0, I get 0. So there is my exact answer for the volume. Now let's do it again doing the shell method. So now instead of slicing perpendicular to the axis perpendicular, we slice parallel. So it hits right there. I'm just going to draw it right there, and it's going to go around and around, and it's going to go behind, and it's going to be a ring like a piece of pipe, like this. So the volume of this pipe depends on how thick it is, and that's this slice right here is the thickness, and so that's a dx. And the distance around is 2 pi r, and r, just like the disk was, to here is y plus 1. So there's 2 pi r, the distance around. Again, if I cut this and lay it open, it makes a rectangle. The thickness, excuse me, is dx. The distance around is 2 pi r. And r is y plus 1. And this, which is what people had the most trouble with, is this length, and that goes from here to here. Now, if this is the point xy right here, this is x. This is the red is what's left of the 2. Here's 2 all the way up, but the width we want is going to depend on this curve. It's 2 minus the x. 2 minus the x is how long this is. 2 minus the x. So the volume of this is 2 minus x is this. That's the volume of one ring, and then I want to do the bigger ones that are shorter up here, and the smaller ones that are wider down there. I want to add them all up for y starting at, this was where y was 0, and this is where y is 4. So from 0 to 4. And everything looks good except that I have a y in this, and y is, oh, the thickness is dy. Why did I call that dx? dy. I am so sorry. That's probably got a lot of you confused. dy. The thickness is dy. Darn it. I'm tired. Okay. So the y is going to go from 0 to 4. And we want to leave this alone. We got to change the x to y's. And if y equals x squared, if I take the square root of both sides, I get the square root of y is x. So that's what I got to put in place of that. So I end up with the integral from 0 to 4. The 2 pi will come out, and I'll have y plus 1 times 2 minus the square root of y. dy, not dx. This one was dx because I was perpendicular going, and the thickness is this way. Okay, so if I distribute this, I get 2 pi integral from 0 to 4 of 2y minus y times y to the 1/2, and this is to the 1. That makes y to the 3/2. Then 1 times 2 is plus 2, and 1 times the square root of y, and its minus is minus the square root of y, or y to the 1/2. dy. Now to finish, we'll integrate this. So we got 2 pi. 2y antiderivative is y squared. 3/2, we have to add 1, which would make it 5/2. And I'd have to divide by 5/2, which is multiply by 2/5. Plus the antiderivative of 2 is 2y. And y to the 1/2, if I add 1 to it, I get y to the 3/2. So I have to divide by 3/2 or multiply by 2/3. And we got to evaluate this from 0 to 4. Since all these have y's in them, putting in 0 doesn't cause anything. So I just have to put in 4's, and I get 2 pi times 16. Square root of y is 2 to the 5th is 32 times 2/5 is negative 64 fifths. 4 times 2 is 8. Square root of 4 is 2. Cubed is 8 times 2, negative 2/3 is negative 16 thirds. And that would be the exact answer, and it's the same as this one if you put it in the calculator, and it comes out to be what was it? Look it over here. Where did I put it? 176 pi over 15. Decimal approximation is 36.861 or 11.7333 pi. These are approximate. I would like to see this answer or this answer. Something like that. Or this answer. Okay. Number 4. Okay. Where do we want to put the coordinate system? In class, I went over this and I put it at the bottom of the tank. So now I'm going to put it at the top of the tank just to show you how that would be. And we should get the same answer. So I'm putting x here, y here, and we're lifting water. We're going to think of this as a bunch of slices of water that go all the way back, making a rectangle. That slice of water, it's a real thin slice like a sheet of paper, but it's a rectangle like that, a box, sheet of paper. So I've got to figure out its volume, because the weight of that sheet of water is 62.4, since I'm in feet, pounds for every foot cubed. Well, this is not going to be very many cubic feet because it's really thin, but its thickness is up and down, so it's dy. Its width is going to change as we move up and down, so I'm just going to call it x, and its length is the same as this, 8 feet. So I'm going to do 8 feet times 2x, 8 feet long, 2x wide, and dy deep, thickness. If I take the weight density times the volume, each of these multiplied, that feet times that feet times that feet, I get a volume. Volume times, we'll cancel the feet cubed, and I get the weight in pounds of that slice. So the weight is a force that I got to work against. And work is force times the distance. So I have to figure out how far I need to lift this. Now, the distance, since we're supposed to be pumping it into a truck 7 feet higher, so up here 7 feet somewhere is a truck. Then we're pumping this in 7 feet higher. So how far do I have to lift it? Well, by putting my axis here, this could be y, and the distance I need to lift it is 7 plus y. Now if I'd put my axis down here, then this would have been y, and the distance I have to lift it is 9 minus y. Now, doing it this way, we're going to integrate y starting at the top, which was 0, down to when y is 2. If I put it down here, I'm going to do y from 0 to 2. So it turns out to be similar there. But continuing with the way I've got this set up, everything's good except for, it's dy, it's y, and there's no other variables except for the x here. So I need to figure out a way to replace x with a y. Well, x depends on this side. If y is small, x is big. If y gets bigger, x gets smaller. So if I write points on here, putting my coordinate system here, the x is 3 when y is 0. When I go down to the bottom, which is down 2 feet, the x is now not 2y, but only 3y is 2y. So I need to come up with an equation of this line. And lines are y equals slope times x plus a y-intercept. The slope is the change in y over the change in x. So if I just go from here to here, my change in y is 0 to 2, or 2. And my change in x goes from 3 to 2, which is minus 1. So my y would be minus 2x plus some y-intercept. Well, if this is the x-axis, this is the y-axis, this will eventually hit down here. It had to go down 2 to get back 1. I have to go down another 2 to move to only 1 away, and another 2, so it would be clear down here at at 6. Now, this doesn't look like a negative slope, but I've got this graph flipped upside down to where this is y, and this is x. And so if I solve for x with this setup, the coordinate system at the top, I'm going to have y minus 6 equals negative 2x, and then divide by negative 2, and x would equal y minus 6 over negative 2. That's what I'd put in for the x, and then I'd type this into my calculator, and I should get an answer that is 39603, and this would be weight times the distance. So the weight is in pounds and the distance is in feet, so I get foot pounds. Okay. Next one. Maybe I should stop this just in case so my